Alright, let's take a look at number 4 together. We're going to break it down into smaller parts because this has a lot going on. Basically, when we're taking limits, we can look at each part individually. So, if we're looking at the limit as x approaches 1 from the right, let's look at what happens with this part up top. As x approaches 1 from the right, so we're going to have a number that's bigger than 1. So like 1.1. If we put that in here, 3 times 1.1 is 3.3. Let's say we get closer, 1.01. Put that in here, we get 3.03. 1.001, we get 3.003. So we can tell, we don't have to write the table down, but we can tell that we're getting closer and closer to 3 for this part alone. So the limit of that part is 3. And to do that, it's getting closer and closer to 3, and we can put a little plus here to show that it's getting closer and closer to 3 from the right side. So it's always going to be a little bit bigger than 3. For this, down in the bottom, if we look at the x squared, the limit as x approaches 1 from the right of x squared. 1.1 squared is going to be a little bit bigger than 1. 1.01 squared, also going to be a little bit bigger than 1, but closer to 1. 1.001 squared, going to be close to 1, but even closer than before. So as we're getting closer and closer to 1 from the right, this part is getting closer and closer to 1 from the right. Let's look at this part. As x approaches 1 from the right, what do you think is going to happen here? Same thing as up the top. 1.01 times 4, we get 4.04. I'm sorry, 1.1 times 4, 4.4. If we do 1.01, 4.04, and so on. So it's going to get closer and closer to 4 from the right side. And the minus 5, there's no variable there, so that's not changing. The limit as x approaches 1 of that is just going to be minus 5. So it looks a little confusing with all these little extra pluses and everything. But if we look at this, the top is kind of by itself. We need to focus a little bit more on the bottom. On the bottom, we're approaching 1 from the right, 4 from the right. All that means is this number here is going to be, it's always going to be a little bit bigger than 1. This number here, always a little bit bigger than 4. It's getting closer and closer to 4, but it's always going to be a little bit bigger. So if we add these two up, we're going to get something that's a little bit bigger than 5. But it's going to be really close to 5 as we keep getting closer and closer to 1. So it's going to be really close to 5 from the right. So that little plus kind of reminds us that it's a little bit bigger than 5. So if we have something a little bit bigger than 5, minus 5, we're going to get something really small in the denominator. So 5 minus 5 is going to be 0, but this one's not 5 really. It's something a little bit bigger than 5. So this one is going to be a little bit bigger than 0, but it's going to continue to get closer and closer to 0. So what happens here? What's our limit as x approaches 1 from the right? This is getting closer and closer to 3, but this one's getting closer and closer to 0. So if we divide by a small number that keeps getting smaller and smaller, what happens is this whole number, this whole thing altogether, keeps getting bigger and bigger. So this is going to approach infinity. Right? For example, try it on your calculator. What's 3 divided by 0.1? What's 3 divided by 0.01? We kind of went through this before up here. Right? In this problem, in number 2, 1 divided by 0.1 is 10, then 1 divided by 0.01. So that gives us a bigger and bigger number. It's going to continue to increase without bound. So this one approaches infinity. All right, go ahead and try part B on your own. Work with your partners, your groups, ask questions. Go ahead and pause this and start it up in a little bit when people are ready. Alright, let's take a look at B. Pretty similar to what we just did up here. Break it down into smaller pieces. So limit as x approaches 1 from the left of 3x. 0.9 times 3, you're going to get 2.7. 2.99 times 3 is going to get closer to 3. It's going to continue to get closer and closer to 3, but it's always going to be less than 3. So it's approaching 3 from the left. So from the left, or think of it as always being just a little bit smaller than 3. For this, approaching 1 from the left, if we put that in to the x squared part, that's going to get bigger and bigger. It's going to get closer and closer to 1 every time, right, as we increase it or get it closer to 1 from the left. But again, it's never quite going to get to 1. It's going to be just a little bit less than that. 4x, so we get closer and closer to 1. 4 times 0.9, 4 times 0.99, 4 times 0.999. It's going to continue to get closer and closer to 4 from the left side. Right, so it's always going to be a little less than 4, but it's going to get closer and closer each time. The minus 5, again, is a constant, so that doesn't change. It's not the limit as x approaches anything of a constant is that constant. So if we look in the bottom now, 1 plus 4, we get 5, right? But remember, both of these are going to be a little bit less than 1, a little bit less than 4. So when we add them up, it's going to come out to be a little bit less than 5. It's going to get closer and closer to 5 each time. We still have that constant at the end. So 5, something a little bit smaller than 5, minus 5. Well, that's going to keep getting closer and closer to 0, but it's always going to be a little bit less than 0. So if it's a little bit less than 0, in this case, that's going to be negative. And if we take this number divided by a negative, kind of like what we had up here, we're going to get closer and closer to negative infinity. So we fall into a similar problem that we had in problem number 2. Right? We're approaching infinity, negative infinity, so that means our limit does not exist.